So, I'm here to talk a little bit about our experience at University of Michigan in rolling out end-tidal control. Just to start with, I am a consultant for GE Healthcare. So just a bit of background, I am the Director of the Equipment and Supply Program at U of M. Really what that means is that I took this over from Dr. Socek here in the second row, who did the job for 25 years before I did, and then handed it over 2 months before COVID with impeccable timing, so thank you for that, Jim. So, it's a big institution. We have 140 anesthetizing locations across 3 big inpatient towers, with another one to come, with another 25 locations there, 500 providers, and we're looking at replacing all of our anesthesia machines pretty much. COVID-19 had just happened, but it's kind of in the rearview mirror, and there was a lot of change fatigue as a result of that. There were financial pressures as well. The machines we had were mainly GE ACES, not the ACES CS squared machine, but the ACES. The majority were approaching end of life, and we've been pretty happy with them. Some of them have got 2 or 3 times as many hours on them as they should have done. We had a few principles in looking at what choice to make in terms of our new anesthesia machines. We wanted everything to be the same no matter where it was. And our residents go to a lot of different sites, and what we really want them to experience is when they are in any situation, the equipment should always look the same. It can be hard to do, and there are minor differences, but largely we like to do that. We talked about the change fatigue. And this involved a few discussions with our capital committee, and the chief medical officer actually asked me in one of these discussions, how will this investment enhance patient safety? And it's a really good question, because you're asking for a lot of money, and just to say, hey, it's just going to kind of do the same thing but newer, probably isn't going to go down so well. So as you can probably guess, we did decide to go with the ACES CS squared with end-tidal control, and for 3 main reasons, and the top one's in bold because I think it's the most important. I see this as a really important patient safety feature. And we'll go into that a bit more. The other thing, as part of the equipment and supply program, I also lead our green anesthesia initiative, and our chair, Dr. Mashur, came up with the Gaia mnemonic form, and it's from Greek mythology. I had to look that up. And the whole point of this is to try and reduce the environmental impact of what we're doing on a day-to-day basis. And in short, what this really means is switching away from nitrous, ISO, desflurane, moving to sevoflurane across the board. That is going to get significantly more expensive, probably about twice as expensive. So to go along with that, we have to cut our flows just to pay for it, but also because that is an environmentally good thing to do. So I just want to take a moment here to look at the safety features of an anesthesia machine. I'm not going to read them all out, but they're pretty much all to do with oxygen. I think there's oxygen in pretty much all of them, apart from the locking common gas outlet. So you can see they're all mechanical pretty much, mechanical ways of avoiding hypoxemia. And then when we look at the ASA guidelines for determining anesthesia machine obsolescence, again, it's oxygen, 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 oxygen again, and then oxygen, potential for human error as well, really important. So, to think about this, how can we avoid a hypoxemic gas mixture? How can we avoid giving less anesthetic agent than we want to? What if there was a system that could achieve that? And there is, as was, I think, pretty nicely demonstrated by the master trial. So, the important features for us for patient safety was the avoidance of this hypoxemic gas mixture, the precise, rapid achievement of our end-tidal SIVO, because we're only using SIVO now target. And then more importantly, this is kind of subtle, but it allows really low flows and then frees up the clinician to think about what they actually should be thinking about. So if you want to run super low flows, you can do that, but you need a system, you need to be attentive and vigilant. Not that you wouldn't be otherwise, but you'd need to be focusing a lot and making a lot of changes to the inputs on the anesthesia machine. And during the kind of long, complex surgeries like liver transplant, you don't really want to be doing that. And I think we can prove in a chart later on that people weren't doing that. Touched on a little bit about this, but at the U of M we used a lot of ISO and nitrous. We didn't use much DES, which was good. We use a bit of SIVO, but our future state is 100% SIVO with our nitrous pipelines decommissioned. We can go into this in a bit more detail, but you can cut the amount of nitrous that you use, but really you have to get the pipelines and the infrastructure out. And the nitrous pipeline at U of M was decommissioned yesterday, which is a great day for me to be out of town. So when we ran this forward, it would have doubled our annual gas cost doing this. So we needed to reduce flows and reduce the amount of volatile that we used. And education is probably the best way to achieve this, but it's never really worked before. And there was no real evidence that it was going to work again. And the thing about a green initiative is you cannot make things worse for patients. You just cannot have an instance of awareness because you made someone who didn't know how to run low flows run it. So this is just a nod to the department here and what they've managed to achieve over the last couple of years. As you can see, we use a lot of nitrous, and now we don't use very much at all. So this is a group of providers who are welcoming change. I think in a department as big as ours, there's 500-600 people in it. This is really very impressive. And I just put this up there just to contrast what happened with our average flows when we launched the initiative, which is coming up soon. So we managed to make the case to the Capital Committee and the hospital at large that this was a worthwhile investment based mainly off patient safety. And then we had then we had to roll this out. Now, because this is a level 3 device, I think level 3 classified device by the FDA, there's a mandated training module that you have to do, and there's a lot of people in our department that we had to get through. We couldn't roll it out immediately, and as a result, we're going to have a 3 or 4 year transition with some machines with end-tidal control, some machines without. That was another concern. And we were worried that people just weren't going to use it. And we didn't really have any way of making people use it. So the rollout actually went pretty well. This is the second time for me. I used this in the UK 12 years ago. We had a converted classroom. We cut the training module down to about 30 minutes, and there's an exam afterwards, which people were pretty good at getting through. We got one machine delivered ahead of time, and I'm going to share the data from that. We put it in our liver transplant OR because that's a small group of attendings. There's about 10 attendings. And then what that did is allow people to come in and sort of play with it, get hands-on, see if they liked it. And then we rolled out to ambulatory sites and then across the hospital as a whole. And we've now got about 50 or 60 machines, and we'll have all 140 converted in about 2 years. So yeah, providers were a little wary at first, I think it's fair to say. People were worried they'd have to watch it more closely than they would normally. What happens if it doesn't work? What will I know if it's not going to work? And is this just about saving money? Because providers are willing to take on new ideas, but if it's all about the money, it tends to switch people off. So we rolled it out. We got everyone through the training. We defaulted the minimum flow to 0.5, which was significantly lower than anyone was doing. And we did remove the agent cost display. It's possible to put it up there. Some people are actually asking for that to be put back now so that people can encourage its use. But we decided to remove it because I really did pitch this to the department as a whole as a patient safety device and something that was going to make their life easier. And this was kind of typical of the wariness around it. I got a text from one of my really close friends. And she said, it's just not working. And it's really interesting because I think a lot of the time people aren't used to their anesthesia machine telling them exactly what's going on. And if you can see at the top there, it says agent mixture, use fresh gas control, start ET control when previous agent is removed from circuit. It tells you exactly what's going on and what you need to do. So this was pretty straightforward for me to figure out. What they'd actually done is they started the case with isoflurane and remembered halfway through we were supposed to be using SIVO. So put the SIVO canister in and then the end-tidal control stopped working, as it should. So yeah, the rollout, the impact, providers like it. We have now settled at 500 cc's a minute. When it's turned on, it's at 500 cc's a minute, minimum flow. We think our total SIVO usage is reduced by about 35% at the ambulatory sites. Maintenance flow is not the whole picture. You've got to get people to turn this on quickly, and largely when people start to use it, that's what they do. Initial feedback's positive. I was working with a resident the other day, and we just secured the airway. Turned around, and she said, "Oh man, we don't have the end-tidal control thing." And people are genuinely upset when they don't have it anymore. I did ask one of our less demonstrative providers for feedback, and he was like, "Yeah, it's good. I just turn it on," which is, I think, perfect. I mean, if there was a strap line for something like this would be it. Someone says that patients wake up faster. I really want to look at that. I don't know why. There's no reason why they would, other than having more precise control of your end-tidal sevoflurane throughout the case. So here's some data from the first machine we installed. And I took this back to 2018, just so you can show that, to make an impact on this kind of line, it has to be something big like a global pandemic. So the top line is case count using volatile in our liver transplant room. And the bottom line is the fresh gas flows. So, COVID is the thing that first makes an impact on this graph as we stop doing cases. But the fresh gas flow really doesn't change. It settles at about 2 liters. And this is based off EMR data between induction end and the surgical dressing complete at the end of the case. Interestingly, and disappointingly, when we launched the Gaia, we did ask people to consider low flows, but as you can see, none of this group did that. They just carried on doing what they were doing. And then it's not until you install the machine that you really start to see a change in flows. And it follows a pretty similar pattern. You get the early adopters. These are people who are just going to use it. You're going to do the training and use it. And then slowly the rest of the team comes on board. And now we're at average flows less than 1 liter, and I think that's because we get some leakage either end of the case into that data. So we must have done 20 or 30 liver transplants now with the flows at 0.5 the whole way through. So my reflections are end-tidal control is easy to use. The early adopters will do the training and use it. Other people may need a bit more reassurance. And what we saw as a downside, the mandatory training and the exam, actually I think increases people's confidence in it, because it makes it seem much more complex than it is. And the most common feedback I have was like, I thought it was going to be hard, but I literally just press start and it works. And with any kind of new thing you're rolling out, super users, cheerleaders, people who are willing to go around and tell everyone else how great it is, are always really important. A few more things I'd like to know. Is your Mac actually more stable with end-tidal control? Do people set a higher target or a lower target when they're just using fresh gas flow? We really want to get on top of how much less agent we're using as we go through the rollout. Here's my wish list. So I want something to control the CO2 as well. Wouldn't that be amazing? Could it interface with our process EEG monitor? Could it perhaps say, hey, your patient's a bit light, you might want to consider deepening your anesthesia? Maybe you could just set a range for your MAC target rather than a specific target, and then it use other data to help figure out where the best position for the end-tidal agent is. And an activation reminder. I really don't like alarms, but this is something I think we could just do with a really annoying alarm that went off, like the seatbelt thing, until you turned it on. And just, sometimes we don't think about the people who make this stuff for us. And so this is from the GE factory in Madison. And that machine there is the very first machine off the production line that now sits in our liver transplant room, and that was the chart that I shared with you earlier. So a thank you to these guys and to you all for listening. Thank you.